All right, great. Thanks, everyone. This is Exposing Dark Data in the Enterprise with Custom NLP. So before we get started, I just want to say, one of my favorite things about coming to these conferences is just to kind of see the experience that we're all kind of going through as data scientists and really kind of to see what other people are doing, how they're approaching similar types of problems, and then come and kind of, take bits and pieces of that, incorporate that into my own solution. And so that's really what I hope to do today for you guys, is just to kind of share some of the challenges that I've been working through, some of my approaches to those challenges, and then hopefully when you guys go back to work on Monday, you can take some of those and incorporate that into what you're doing. So with that said, I do want to say that I do not have the magical solution for NLP pipelines. I'd be a little bit skeptical of anyone who said they did. I mean, the bottom line is that human language is very complex. Humans are very complex. And so with that said, these are just some approaches that I like to do. So a little bit about my background. In 2012, I started working on my first commercial product. In 2014, I commercialized my first product, and that was a document management system aimed at digitizing data assets for different enterprises. Wasn't too heavy in any hardcore NLP. There was some fuzzy matching. There was a very strong OCR component, but in terms of some of the advanced NLP concepts, wasn't necessarily incorporated yet. And then in 2017, I commercialized my first true NLP product. Immediately started panicking, said there's no way I'm doing this right. Went back to school to study. Felt a little bit better. Did make some changes and some upgrades, but overall, these are just kind of some of the lessons that I've picked up along the way, and just some of the scar tissue as well. So today, I'm really going to talk about a couple things. First, NLP is a two-part problem. The first part, which is the whole modeling component, I think is something that we're all very familiar with. The other major component, especially in the enterprise, and especially dealing with dark data, is feature extraction, which is pretty much part of feature engineering. And this is a component that really especially in academia, does not really get a whole lot of love and attention. It's kind of like Cinderella that, it's ignored, but it's extremely important, especially when you're dealing with dark data. So most of the time, and what I mean by dark data, in enterprises, it's very rare, and some enterprises have this, but most enterprises, it's very rare for them to actually have someone sitting down, annotating and structuring text for you. In many cases, and in many of the situations that I've worked in, you're basically just getting a document dump. I mean, there's no annotations for entities or intents or topics within any documents. There's no prior labels or classifications that are given to you. It's basically just, going in and doing a lot of that feature extraction on your own. And so, anyway, with that said, in enterprises, there's a very limited amount of labeled data, sometimes none at all. There's domain-specific terminology, which I'll discuss more in a second, but this is another big one in terms of adding some constraints to what you can do with commercially available software or open source software. Is that there's company-specific terms, there's product-specific terms, there's specific terms within domains that are not openly available, and these are some things that you have to kind of build yourself. Another major component is grammar, spelling, and syntax. So a lot of times, especially when maybe you're doing classwork or maybe you're doing online tutorials, the corpus that you're analyzing are often Wikipedia articles or news articles, things that are very eloquently written. Things that are written by journalists who have editors and other resources to really create literature masterpieces. And the bottom line is, in the real world, in a lot of enterprises, people don't write like that. You've got many different authors, which means you have many different vocabularies. You have a whole lot of different grammars and styles. And a lot of times, a lot of that is really unreliable. So there's some additional steps, additional processing there that needs to happen. And then finally, training availability. With any kind of machine learning project, it does require some domain and human expertise to go in and train, and that's almost always going to be limited, especially when you get to more specific use cases. That expertise is very expensive and time-consuming to rely on. And so really kind of some of the approaches, some of the tips and tricks that I plan to share today are really, is a bit more of a balanced approach. So really understanding your corpus, some ways to add domain knowledge, and then creating some flexible machine learning processes. So I'm just curious, who here has completed an NLP project or is an NLP practitioner? Okay, so a handful, and I know I'm not the first NLP talk of this conference, so I'll do a quick little introduction, and then I'll kind of jump right into challenges in the enterprise, some of the things that I've come across, and then we'll go through a specific example, and then I'll also demonstrate that example as well. So, all right. So, what is natural language processing? And again, I know most of you probably already know this, but it's basically teaching machines to understand human language, and for the most part, pretty much everyone should have already been dealing with this with search engines like Google, with virtual assistants and chat bots. So why is NLP hard? And really, the way I like to describe this to people is it's broken up into two parts. One, it's very, very deceptive and misleading, and two, there's a lot of information, a lot of context that's required to really understand it. And so the first part, which is kind of this idea of illusion and almost deception, can, just as an example, are news headlines. And so human language can be very misleading with some of the things that are said and can be interpreted in multiple different ways. So for example, teacher strikes idle kids, stolen painting found by tree, and these are real news headlines, by the way. Hospitals are sued by 7-foot doctors. Kids make nutritious snacks. So anyway, these are a couple examples of the first part of this quote, and that human language can be misleading and very very deceptive. The second part of this quote is basically what our eyes, or what reality, what we can't really see. And so this is just a very simple sentence, very simple sentence structure. And in fact, most of the grammar, the syntax, and vocabulary even stays constant throughout these examples, but they have very, very different relationships. And really all we're doing is switching out one word, but here you can see there's multiple different ways to eat spaghetti, and unless you're bringing in outside context, you really don't know which way you're talking about just by reading the text that you see in front of you. So those were just some very simple examples to show that human language is very, very difficult to understand, and really what it comes down to is that it's very, very noisy. Now we'll get to some more complicated examples in a second, but those are very, very short pieces of text. So anyway, the point is that before you get to any kind of modeling, it's really important to realize that you have a noisy text, you've got to pick out the right features, and that becomes very, very tricky. And so what I want to do to kind of visualize this is a very simple NLP pipeline. It's certainly, there's more things you can do in terms of lemmatization. There's certain things you can switch around, but this is just a simple example. And one of the things that immediately jumps out is that this is a very linear process. So basically, what that means is if you screw up in the beginning, it's going to make the end screwed up as well. So if you look at this and were to break this apart into components, really, most of this is feature extraction. Basically, all of these prior steps, which are in blue, are to extract out the features, the variables that you're trying to model, downstream and in the end. So, anyway, since this is a linear process, I just want to highlight that feature extraction is very, very important, especially when dealing with messy text, because it dictates two important things in your downstream modeling. First, the more accurate your features that are extracted, the more accurate your modeling is going to be. If you're just extracting noise and garbage, and you try to model noise and garbage, and your models are not going to be as accurate. The second thing is that when you extract features, ideally you're also leaving out a lot of the garbage, a lot of the noise that's left in text, and what that does is that speeds up your modeling as well. As many of you know, NLP deals with very, very sparse matrices, and some processes downstream, like topic modeling, can be very computationally expensive, especially when you get to things like hyperparameter tuning and running multiple iterations through a model. So That also, by extracting out features and leaving out noise, it also speeds up the speed of your models. So to kind of step through a very, very simple example before we jump into doing an enterprise, this is just a small project I did a couple years ago. This is on a very, very small scale, very similar to stuff you've probably already seen, but basically analyzing reviews. And so for this specific example, this was for hotels. Basically, they wanted to analyze reviews. They had a whole bunch of different data sources, and they wanted to make some strategic management decisions based off of what their customers were saying. Now, they had a whole bunch of reviews that they needed to analyze, and really the deliverable for this project was this guest satisfaction scorecard. So I'm a manager or I'm an owner of a hotel. What am I good at? What am I not good at? And similarly, in terms of my competitors, where are they beating me? What are they doing better than I am? So from a very high level process diagram, this is pretty much the NLP pipeline. So basically, grabbing the text, formatting it, processing it, breaking it apart, doing some very simple feature extraction. So the only two features that were extracted here were sentiment and entities. And then those entities were mapped to a topic, which were these were the topics down here. And with those topics, basically they consisted of entities. Those entities were tagged with sentiment. And then we were able to produce that scorecard, which I'll get to in a second. So again, this is kind of a simple example, but in terms of NLP, where do you start? Well, it's very similar to any kind of data analysis. You start with exploration, and certainly there are a lot of different options here. I threw up a couple here just to kind of shotgun a couple. But for example, you can do a lexical dispersion plot. This kind of just shows the instances of which a certain entity or topic may appear within a text. So this is the book of Genesis. You can see Adam and Noah appear early on in the book of Genesis. Joseph appears at the end. This is just one simple technique. You can measure some descriptive statistics like lexical diversity. That shows basically how frequently each word appears. And so if you've got a lot of lexical diversity, that means you've got a very high range in vocabulary. There's some other things as well. And if anyone is interested, there's an NLTK tutorial that I wrote that kind of walks you through some of these that is pretty quick to do. So anyway, this is kind of just a high-level overview, and again, this is just a quick example of a quick snapshot of what you can do of your corpus. You can capture some high-level statistics, and again, there's some of the libraries I use down there. For sentiment analysis, basically what happened here was that based off of those, basically classifying each review, after POS or part of speech tagging, what you can do is you can basically pull out the adjectives, the descriptors, and then create a word cloud from these. And then finally, like I was saying before, map the entities to a topic. In this case, this is a scorecard, and we can see basically overall how this hotel performed. So this is a simple hotel review example that is again pretty straightforward. All right, so let's add a layer of complexity here and talk about the enterprise. So in the enterprise, there's a couple more challenges, and by a couple more I mean a lot more. And this is by no means an exhaustive list. These are just some common ones that have reoccurred. And so for the challenges that are pertinent to this discussion, I highlighted a few that are very commonly focused specifically around NLP in the enterprise and things that I've come across. So really, I think the best way for me to address some of these is to walk through an example. And this is, so the example I'm going to walk through is specifically for a very, very large enterprise in the oil and gas services industry. Specifically, what they were looking for was an information retrieval system. So this is almost like I don't want to say a search engine, but it's basically a search engine. You ask a question in natural language, and then it returns an answer found in the documentation. So the problem, I guess the problem is currently the way that they do this. Basically, you have a customer. The customer calls and has an issue. typically the customer service representative, which is an operator or technician or even an engineer, will start trying to troubleshoot the issue. And the problem is that a lot of this information is new to the customer service representative. So what happens is that generally in these types of positions, there can be high turnover, there can be some tribal knowledge that's lost, and basically what happens is there's this whole finagle to go and chase down the correct answer. There's a lot of discussions that are happening between people, and then even between those people, there's a lot of documentation that's searched and difficult to find. Now, this industry has been around for a while. Oil and gas has been around forever, and so there's already a lot of documentation that has that knowledge captured inside. The problem is that knowledge is very, very difficult to find, and it takes a very, very long time. So in this case, in this information retrieval system, what this company wanted was really just one person to chase down the issue, and basically they knew that, hey, we've got this whole corpus of documentation that has all these diagnostics in it. We just need to be able to find it faster, and so hence this is why they wanted an information retrieval system to get that information much faster. So in terms of approaching this problem, first, before even getting to a solution, really trying to understand the constraints of of the problem. And so, like I mentioned before, this is dark data, so it's unstructured. There's no previous annotations. This is basically just a document dump, and what that does is that's going to limit a lot of the things you can do. So, with supervised machine learning, there's some limitations on that just because you don't have as much labeled data. Now, as you acquire more, you can incorporate that more. And then the other thing is that there's some extra effort needed for feature extraction, meaning that these documents, these texts, again, they're not tagged with entities. You really don't know if some of these documents even have any value whatsoever. And so, there's kind of this hyper-focus, this emphasis on making sure that you're extracting the right features for your modeling downstream. And then you also need to understand your corpora. So this gets really tricky because in the enterprise, again, you've got multiple authors. They've got all different kinds of styles of writing. And so I'll step through some examples of kind of the different type of corpora that you can come across and the limitations of each one. Unreliable grammar, spelling, syntax, punctuation. So a lot of times, this often will have some importance on what kind of modeling techniques you use. So for example, if your grammar is inconsistent or incorrect, you'll be limited with sequence models, and you might rely or lean more heavily into bag of words approaches. With spelling, there's certainly some commercially available APIs and open source tools you can use to correct spelling. But then there's also domain-specific terminology where you have to employ things like fuzzy matching and stuff like that to correct spelling. So unique terminology. So this is another constraint. I've touched on this already, but basically this idea of, okay, there's specific terms that are unique to that company or unique to that industry or unique to that product or unique to that company's customers that need to be accounted for. And so basically you need to define those and make sure you incorporate that knowledge, especially into your NLP pipeline. And then finally, this idea of training availability. So basically, this limits the amount of additional labeled data that you can get. You already started off with none to a limited amount. Eventually you want to get more and more to see how well your models are testing. But you have to be cognizant that every training iteration that you go through, you have to make it count. This isn't. A lot of these organizations don't have people who are sitting around just waiting to test your models for you, especially because this knowledge is very specific and very expensive to acquire. So in terms of, so these are some of the challenges in terms of how to approach these. these are a couple I like to look at. So first is the machine learning aspect. And so with machine learning, we have some constraints. With that said, really what you're trying to do with your machine learning is a couple things. One, as I said in the beginning, there isn't really a one-size-fits-all solution. You're going to have a very wide range of variance and distribution in terms of how your corpus is structured. So one of the things you want to do is you want to add a lot of flexibility into your NLP pipeline. And this isn't really anything too crazy in terms of the modeling approaches. So you will, like any data science project, you will try multiple modeling approaches. But what is a little bit different about this is your feature extraction. So what's happening here is that you actually break apart your feature extraction and you add multiple steps here. And I'll go through an example of what this could look like. But basically, you employ modular programming and you're able to switch out different functions to either reduce noise or extract features or do some kind of combination of each one. So an example of what this could look like, and I'll walk through a few here. But and this is one of the more simple ones, and I'll go through a more complex one. But one thing you could do here is you have a text. You can reduce that text by just removing stop words, and this can be by using the stop words dictionary in NLTK, or maybe you create your own. Then you extract features, extract entities, and you can do this a couple different ways. You can use lookups. In this specific example, you can use part of speech tagging and write your own custom grammar to pull out things like noun phrases, and this is, again, easy to do in NLTK. And then finally, you go through a modeling approach. So this can be something as simple as doing a vector distance calculation between the text and a similar text vector within your corpus. So some more complicated examples, and this kind of ties back into understanding your corpus. So technical reports are generally written very well. The grammar is very reliable, and part of that is because they're reviewed multiple times and have multiple authors. So one of the things that allows you to do is that it allows you to extract some additional features that you usually wouldn't be able to extract. So for example, one of the things that in this example is that you can do subject predicate object triplets, and based off of that, map those to an intent, and now you have an intent feature, as well as all of the other features that you would normally collect, like entities, and maybe even some topics as well. An example on the right with the Q&A. Q&As are kind of open for anyone to submit to, and generally aren't reviewed. Spelling grammar is pretty off, so things like grammar and spelling are not as reliable, and so capturing things like intent become a lot more tricky. And really what happens is that you have to be very conservative in terms of what you extract, because you don't want to lose any information from the text that's there. So in this case, it might be easier to just kind of whittle away at the text and gradually, iteratively reduce the noise until you're left with probably still a lot of noise, but at least less than you had before, and then map those to a topic model, such as something like LDA. So the second thing that we can do here, in addition to some of the machine learning approaches and building this flexible pipeline with different feature extraction methods, is adding to the ontology and the dictionary of our NLP pipeline. And so with enterprises, there are, again, domain-specific, company-specific, product-specific, and user-specific terms. And these are terms that we need to teach our NLP pipeline. Otherwise, it's not going to be able to extract some of these terms. So an example term that I like to use is something like SEC. If you are a college football fan, SEC is going to be domain-specific to a football conference to you. Whereas if you are more in equities and investing, SEC is going to become it stands for Securities Exchange Commission. So again, there's some domain-specific terms here that we want to add to our NLP pipeline. Now the question is, how do you add these effectively? Because no one really wants to sit there and just pump out a dictionary that says, okay, SEC equals this and this and this, and here are some of the other terms that can also mean SEC. Well, the answer to that is that it depends. And it depends on really the size of your corpus and really how much effort you're allowed to put in. So one of the ways that you can build these dictionaries is kind of the manual way, where you have a domain expert sit down and and pump out these things. Or you can use more statistical approaches, such as word embeddings, which I know we've gone over a couple times at this conference. I'll go over in a second. But basically, either way, you need to teach your NLP pipeline to equate certain terms and certain similarities and certain relationships within each other. So the example I like to use is with iron and Fe. So Fe is the chemical symbol for iron, and if you were to try to equate those in a dictionary, if you were to try to equate those in general, it would be very hard to do just out of the box without any kind of learning material. So, for example, if you wanted to do something like fuzzy matching, it would be very difficult to match iron and Fe with each other because they don't share any of the same characters, and they're very, relatively speaking, very different lengths. Now, if you have a very, very large corpus that has multiple mentions of iron and Fe, you can use a more statistical approach like word embeddings. Or if you don't, it might just be easier to just manually create that yourself. And then the final approach here, the third approach, is corpora understanding. So corpora are different within an enterprise. These are just three simple examples with technical reports, Q&A forum, and reference manuals. So some of the things that you want to look at, and that can vary tremendously, and this kind of goes back to building a flexible pipeline, is your corpus size, your lexical diversity, and your grammar and spelling. So there's a couple things here. First, understanding your corpora is going to be an iterative process. Machine learning is about progress, not perfection. So the more that you iterate, the more progress you're going to make. And early on, you can do some simple statistics that I mentioned earlier, like lexical diversity and that kind of thing. But ultimately, you're going to learn more things about your corpora as you build out your pipeline and as you run the corpus through your pipeline multiple times. The second thing about this corpora understanding is that there's really lots of possibilities, lots of different things you can do to understand this. There's a talk later today about Yellowbrick, which has some great tools. Another thing you can do are word embeddings, which you can use then to map relationships between entities. You can do, and these are again just some simple examples, but you can do simple things like frequency distribution, and then also some topic modeling. This is done with LDA Viz, which is an open source library that you can use to kind of see which words and which words are prevalent within certain topics. So overall, this is kind of this is again kind of a general approach. So machine learning, domain knowledge, and corpora understanding, combining those three. One thing I do want to mention with training especially is that because you have a limited number of labeled data as you train, basically your machine learning models are going to learn from your trainer, and this is kind of a lesson learned is that, machine learning models, they learn from whatever you teach it. So if you were to ask a machine learning algorithm, hey, if all your friends jumped off a cliff, would you jump off a cliff? It would say yes, it would. And that's really the lesson learned here is that I've deployed this product before for other companies, and eventually you'll get to a point where the trainer isn't exactly sure what the answer should be, and so they'll start guessing, and that actually impacts the model in a negative way. So to kind of show kind of the lift that you get with this approach, this is with a corpus for the oil and gas industry, basically just employing a single NLP pipeline. F1 scores, not that impressive. Trying multiple pipelines, you get a little bit of lift in your F1 score. And then finally, when you do that enhanced feature extraction with adding those custom dictionaries and adding multiple, modular programming with your feature extraction, you get that lift. So what I want to do real quick is to kind of just demonstrate a simple example of this. So this is one of the NLP products. This is a website called Refining Online. It's free. You can go in. You just have to create an account. And so I'm just going to type in a simple question in natural language. So I would say how to raise isobutylene. And what it's doing right now is it's searching across the corpus to find similar documents. And so you can see here that the answers that it comes back with, yes, there's some entity recognition there. But one of the other things that you can do, and these are actually drawn from technical reports. So like I said, you can do some more advanced feature extraction, things like doing intent modeling. So even though I don't explicitly say, even though I know the answers explicitly say raise, it knows that I'm trying to increase isobutylene. And that's kind of what, those are the intents that are mapped within this document. So preserving isobutylene, increase isobutylene, so forth. And so, for the sake of time, feel free to go in on your own and play with that if you'd like. So anyway, just kind of summarizing things up. So some additional challenges in enterprise, especially considering that most don't have annotated labeled data for you. One that so there's really four that I kind of want to share, and that's there's minimal labeled data, minimal annotations, domain-specific terminology, huge range in grammar, spelling, punctuation, all that, and then training availability. The trick to overcoming a lot of these revolves around feature extraction. Yes, modeling is important, but if you don't know your feature extraction, then your modeling becomes a heck of a lot more difficult. And then also building just flexibility within your NLP pipelines, using modular programming, allowing yourself the flexibility to handle all those different types of authors with their own styles and vocabularies and all that. So anyway, that's all, and I'll take questions now.
Thank you. So we just got time for one quick question, then we gotta.
Great talk, thank you. How do you manage expectations with the customer where, just use artificial intelligence, or if Google can do it, why can't we? Or I gave you a big computer, why isn't this done already?
Yeah, that's a good one. Yeah, I think there's certainly a lot of hype going on around with AI and managing customer expectations. I think the important thing is to try to partner with them as much as you can. I think the problem comes is when they put all the responsibility and all the liability on you. And so in this specific example, especially with information retrieval, this is machine learning, and if you have good trainers, it will improve. And so I try to influence them to put some skin in the game as well, and to basically have them take ownership, especially with the domain knowledge and expertise that's required to train something like this.
All right, thank you, Justin.
Okay, great.